What's up YouTube, Mystery Lane back with another video. We're here on TinkerCAD. We have created a new circuit in TinkerCAD, and just to make sure you know where that is, here's the main menu that pops up. I've got these little options over here to the side. I want to make sure I'm on circuits, and I'm creating a new circuit. Okay. For our circuit, we're going to be using a miniature breadboard, so I'm going to search for breadboard and bring out this breadboard mini. And if I click on it, somewhere where it doesn't light up with one of these little red dots, right, somewhere like in the middle here, I can have that blue outline, and I can click the R key to rotate the breadboard. So I'm going to rotate it and have it in that orientation. I'm also going to search for an Arduino. I'm going to pull out an Arduino board. So let's get one of those out here. And I'm going to rotate that as well so that my pins here, all my digital pins, and I have a ground connection as well. Got my digital pins 13 all the way down to 0 and a ground pin conveniently on this side near my board. There's also two other ground pins over here. Could use those if I really wanted to, but all I really need for this circuit is one ground connection. All right, so let's clear our search filter and let's pull out our LED. Okay, now remember, LEDs have polarity. There is a positive side and a negative side to the LED. The longer leg is the positive side, and the side with the flat edge is the negative side. So this side needs to be the one that connects to the ground, and I can do that there just for right now, but I'm going to delete that. And the positive side needs to be able to connect to one of our digital pins. So keep that in mind as we're going through here. LEDs have polarity. It matters which side you hook them up to. So let's pull this LED over onto our breadboard. We'll go here to row 3, and I'm only putting the negative side of the LED into this left side of the breadboard. A lot of people in class today, when they're trying to hook it up, they hooked it up like this, and this will not work. This creates a short circuit because with both legs connected here, the electricity can actually bypass the LED entirely and never go into the LED itself. And short circuits are really bad. They can damage your equipment, so you never want to create short circuits. Okay. All right. Now the positive side, so since we've got only the negative terminal there in column F, we want the positive side to connect over here to column F, row 3. And we are showing that with wires on here on TinkerCAD, but in real life we'll be able to bend the pins on our LED in order to just bridge this gap here in the middle, this dip socket gap that's in the middle of the breadboard. Our negative side of the LED now is in row 3, so we want to be able to create a jumper wire connection from row 3 over here to our ground. So let me move things around so everything's nice and neat and straight. Of course, with wires, that'll never be the case. Nothing will ever be nice and neat and straight when you're working with jumper wires. But at least it makes this diagram easier to follow. I also need a resistor, so I'm going to pull a resistor out. I'm going to change it to 220 ohms. So typing 220, changing the units to the regular omega symbol. That's the symbol for ohms. And I'm going to drag the resistor over here onto the board. Now, in this orientation, this works pretty well, but it takes up a lot of space on the breadboard. I'm going to go ahead and go through the example with the resistor connected like this. I have it one end connected to row 3, the other end connected to row 7. And then after we go through this example, I'll go back and show you how to take up a little bit less space. Okay. So we've got a resistor because we don't want to just plug the LED into the pin. That would be too much electricity and it would melt our LED. So we're going to use a resistor to limit how much electricity gets to that LED. And then from row 7, we can now make the connection to our digital pin that we're going to use. So I'm just going to kind of try to make some nice, neat right angles here for my wires to keep things looking nice and neat. I'm going to go up here to row 3, or to pin 3. And I'm going to make that wire red to keep our color code here. Okay, so here's my basic circuit. I can now control this circuit with some code. So if I go over here to code, I'm going to change this. This is more of a Scratch style coding interface, so you can use this to program, but we are learning to program with our actual text commands. There's code already written there, but I'm going to go ahead and retype it just to kind of pace myself and go through things as they should be. All right, so I've got my whole circuit here, and I can trace the path of electricity. I'm going from pin 3. That's not a negative sign. That is a squiggly tilde symbol. That means something called PWM, which we're going to talk about eventually, but we won't need to worry about it just yet. So we can follow the electricity through this wire, kind of trace a path. We go up into row 7 of our breadboard, and that connects to one end of our resistor, so the electricity can now go up through this resistor into row 3. It has nowhere else to go in row 3 except across here to the positive connection on our LED, the anode. And it can go up through the LED and come out the other side on the negative terminal of the LED. And now we can jump from this row here to the ground connection on our Arduino board, because that's what we're using the jumper wire for. Okay, so you won't have this red wire here on the actual real circuit board. You will have the resistor, you will have this jumper wire here. In our code for our most basic Arduino program, the first thing we need to do is tell the Arduino board that we're going to be using pin 3 as an output. So the command for that is pin mode, and then we need parentheses because we need to give it a couple parameters. We need to tell it which pin number, so that's 3. And then we need to tell it that we're going to use that pin as an output. Okay. Then in our loop, we're going to use the command digital write to control the pin. So digital write needs 2 parameters as well. We need to tell it which pin number and the fact that we're turning the pin on. So high is the word for on. Then we're going to wait for 1 second. And then we're going to come back here and do another digital write. And this time we're going to turn pin 3 off. So low is what we want to type, not the word off. And then we're going to wait for another second. So delay 1000 tells the computer to pause on this line of code for 1000 milliseconds. It doesn't do anything else. It simply waits there on that line. And what this does is it gives the computer time to let our eyeball see that this light is in fact off. When I run the simulation now, it turns it on, then it gets to this line and it waits for 1 second. And then it turns the light off, and then it gets to this line and it waits for 1 second, so the light is on 1 second, off 1 second. I can play around with these numbers. Right? I can stop my simulation here in order to edit my code. I can change this to a 100, and now the light will be off for much less time. So you can see it's blinking a little bit faster there. It's still on for a long time, but it's not off for as long. And then I can alter the on time, so it's only on for 1/10 of a second. And now our blinks are much faster, so you can feel free to play around with that a little bit. Okay. Now, another thing I could do here, and what commonly happens when you're building prototypes of circuits, it's maybe I find out I don't actually want this to be in pin 3, but I want it instead to be in pin 5. And that's kind of annoying now in my program, because there's now all these different places where I have to go and change my pin number everywhere that I wrote down the pin number. So a convenient thing to do for that is to create a variable. So I'm going to go up here, and just like in processing, we have the same kinds of variables, or the same types of variables. So I'm going to declare a variable of type int. I'm going to call it red, and it's going to equal 5. Red 5. I'm going in. Right? And now, instead of typing the number 5 in the rest of my program, I can replace all those instances of pin 5 with red. And when I can run my code, it'll work. I can move my wire somewhere else. So let's stop the simulation and move the wire to pin 7. And now, instead of having to change all those lines of code to pin 7, I just change this one line to pin 7, and I'm good to go. Okay? So I can change it back to pin 3, come out here, go there, and now I'm good. So one more thing before I set you loose on building your own traffic light. Okay, so you can bring in these LEDs. You can have a yellow LED. You're also going to need to bring in a green LED. Okay, you can also copy things. So I've highlighted this resistor here. I can Control C, Control V. So now I've got another resistor. So I could get another circuit going there. Okay, so you can copy and paste things in here. But another thing I can do is make this resistor take up less space on the breadboard, because right now I'm wasting sort of these other rows on the breadboard. So I can move this off and rotate it, and now I'm only going to be taking up 3 rows instead of 5. So got that connected there, but if you notice, I'm connected at J3, but I'm not connected anywhere in row 5. Row 5 is not connected to the resistor yet, so I've got to make sure I connect the terminal of the resistor into somewhere in row 5. Right? I can change the color of that to red. And now, since I'm in row 5 for this resistor, now I'll need to move this wire here. Let's see how we do that. So let's, I want to move that node. Nope, that's not working. Let's try this. Click there. Click there. I can't delete things. All right, so the other option would be to click the trash can. Okay, it's not letting me delete my wires. Why isn't it letting me delete my wires? Click, trash, black, trash, delete, delete. Okay, so this isn't going as well as I planned. Backspace is not working. That worked. That worked. Okay, well, it was just a little picky, I guess. Let's try that again. So now I am in row 5. I want a jumper wire that connects row 5 to the digital pin that I want to use to control the red light. So I'm going to go back to pin number 3. I'm going to change the color of this wire to red, and now I'm taking up much less space on the breadboard. So there we go. I can adjust some of my nodes because I don't like the way that that's not at a right angle. So after you've got a wire drawn, you can click and drag these nodes to move the wire around. Try to keep them in nice, neat, right angles to each other. We don't want a bunch of crazy wires going around all over the place. That just makes our diagrams difficult to follow. Okay, so obviously you'll add the yellow and green LEDs to your circuit. And once you add those yellow and green LEDs to your circuit, along with resistors, don't forget a resistor for each LED, you'll also need to add lines of code. So we have this line of code that controls the output for the pin. We got a pin mode line. And we've got lines to turn the light on and turn the light off. So you'll need to duplicate this idea, and you'll need to get it in the correct order. So let's talk about the order of a traffic light, since I found out that most of you have no idea how a traffic light works as far as the color patterns go. So it was kind of disturbing to find out today, but I guess it makes sense. None of you are driving yet. You're just always on your phone in the car. So let's see. We want to have first the green light is on, and that's going to be for a relatively long period of time. After the green light is on, so the green turns off, and at the same time the green light is turning off, yellow turns on for a short period of time. And after the yellow light turns off, and actually at the same instance that the yellow light is turning off, the red light turns on. And this is a very important note. Okay? There is never a period of time where there are no lights on. There should never be no lights. That's not correct grammar. There should never be a period of time with no lights on. There we go. That was a good sentence. Okay, so there should never be a time with no lights on while the traffic light is running. That would be really confusing to motorists and cause accidents. So at the same time that the green light is turning off, the yellow light is turning on. There's no delay between those two. At the same time that the yellow light is turning off, the red light is turning on. There's no delay between those two. So follow that pattern, add the lines of code that you need, build your circuit correctly, and you should have a working traffic light. See you later.